Okay, hello guys, how are you? I hope you're doing good. Okay, today we're gonna learn something about circuits. Today we're gonna learn the difference between series and parallel connections. Okay, so far we've been working with circuits with maybe just one element, like this one with a lamp, a switch, and a lamp. But in real life, we never use. So there's very strange that you use just one element. Normally, for example, at home we have different elements like the washing machine, the microwaves, the lamps. So normally we connect different devices. We connect more than one, and there are two main ways to connect devices. Okay, the first one is series connection. Okay, series connection, we have the elements one after the other. For example, you have three lamps here, and they are connected in the same lamp. Okay, one after the other. The other way to connect elements is in parallel. Okay, parallel connection means that they are in different branches. Okay, in different paths. Here you have three lamps as well, and they are connected in three different paths. Okay, so they have advantages and disadvantages. For example, series connection is easier to connect because you had to use less cables or less wires. But we have a problem. The problem is that imagine that you have this circuit with three lamps. If one of them is broken, the other two will stop working. Right? They will stop working. So you have, for example, here you have three lamps working perfectly well, and if one of them is blown up, or if you take one out, the other two stop working. Okay, so this is something that doesn't happen with a parallel connection. Parallel connection, if you have a circuit like this and you have a problem with one of the elements, for example this lamp, the other two will keep on working. Okay, they will keep on working. You have here this example with parallel connection. So if we take out this one, for example this one, the other two will keep on working. Okay, because the current will take a different path. So this is the reason why normally we use parallel connection. Okay, another thing I want to tell you is that from now, when we calculate circuits, when we are using the Ohm's law that you already know, instead of using different symbols like a lamp, a motor, a buzzer, or a resistor, in general we will use the symbol of the resistor. We will use this or this one. They are the same. Okay, why? Actually, for the electricity, when the electrons are coming this way, through a lamp or through a motor or through a buzzer, for the electricity it doesn't matter whatever you're using. For the electricity, everything is just a resistance. Okay, so that's the reason why we won't draw lamps or motor. We will draw always, when calculating, and I'm saying, we will draw resistance. So, and notice that this is the symbol, but you will find many times this symbol. Okay, we can use this symbol as well to represent resistance. So, for example, if you have this circuit with a lamp, a motor, and a buzzer, if we want to calculate the current or the voltage or different things by using the Ohm's law, we will draw the circuit like this with resistance. Okay, or maybe like this. It's exactly the same. It's equivalent. So we will draw resistance 1 will be the lamp, resistance 2 will be the motor, resistance 3 is the buzzer, for example. Okay, this is what we're gonna do. Okay. So when we draw a circuit, if we draw a series connection circuit, we draw a resistance that can be a lamp, a motor, or whatever, after the other. Okay, and in parallel connection, we draw a resistance, and in a different path, a different branch, in a different cable or wire, we draw the other resistance. So this is a series connection, and this is a parallel connection. Okay, this is the difference. So the first difference is that in a series connection circuit, the current takes just one path. Okay, and we have the same current in both resistance. While in a parallel connection, the current is taking two different paths. Okay, so the current is going to be different. It will be different depending on the value of the resistance, and then the current comes together again to get to the negative terminal. Finally, another difference is that we have a problem with one of the resistance in series connection. There is no current, okay? The current is zero, okay, because the circuit is open. While in a parallel connection, we have a problem, for example, with this resistance. The current can take still the other path. So the current in this case is not zero. It's zero in this resistance, but not in the other, okay? Goodbye, guys.